Hi, my name is Doctor. Welcome to today's astronomy video about giant exoplanets. This is the first exoplanet that was found around a sun-like star. That was discovered in 1995 with the method radial velocity, which measures the movement of the star. This star is the 51 Pegasi, which is a sun-like star, G-star, at 51 light-years distance. The planet is 51 Pegasi b, has half the mass of Jupiter, and is just at a distance of 8 million kilometers, which makes this planet a hot Jupiter. This is another image, artist's image of a hot Jupiter. Now we know about 1% of G-stars, sun-like stars, have a hot Jupiter. The current theory is the migration theory. This kind of Jupiter was formed further outside the system, and it interacted with the existing dust disk and migrated to the inner parts of the system, very close to its star. This picture is silicate clouds, and this was predicted for temperatures above 1400 Kelvin. One such world could be the giant planet Epsilon Andromeda E at the distance of 44 light years. This is another nice animation. This shows you the planet 55 Cancri E at a distance of 41 light years, transiting its star. This planet has a mass of 9 Earth masses. This is another method to detect exoplanets, that is the transit method. Imagine if another civilization were observing our sun. Then it would measure a dimming of the sun by Jupiter of 1%. And a terrestrial planet like Earth or Venus would dim the sun just by 1/10,000th. And this is another very interesting system. That's JWST, another G-type star like the sun at 1400 light years distance. It is more massive than the sun with 1.4 solar masses. It could be that this star has 2 potential M-star companions. M-stars are red dwarfs. And you can see a deformed hot Jupiter. And the question is, this hot Jupiter systems, can they have a Earth-sized planet too or not? This is not answered yet. This is a picture of the planet that is a companion of the star. That's JWST 12b. That's a black hot Jupiter at just 3.5 million kilometers distance. Has a very low albedo. Albedo means reflectivity. It's a very dark planet. Another difference to our solar system is the high carbon-oxygen ratio of 1. And the sun has a ratio of just 0.54. So it's known that in the inner regions of the Milky Way, the carbon-oxygen ratio is higher. There's more carbon. This planet has a mass of 1.5 Jupiter masses. It is tidally locked, and it's slowly spiraling towards the star. It has just 10 million years left, and then it will fall into the star. There's another star that is comparable to Sun. That's the Kepler 7, another G-type star with a mass of 1.35 solar masses at a distance of 3090 light years. This system is younger than our solar system. It is 3.3 billion years old. This is the planet that is in this system, Kepler 7b. For comparison, at the left you can see Jupiter. Kepler 7b is a puffy hot Jupiter at a distance of just 0.06 AU. 1 AU is the Sun-Earth distance of 150 million kilometers. The planet Kepler 7b has just 43% of Jupiter's mass, but there's 1.5 times Jupiter's size. Earth's temperature is 1540 Kelvin. And the data from the Spitzer and Kepler telescope have shown that there's a heat transport from the bright side to the dark side. This is another hot Jupiter, that's HD 209458b. This hot Jupiter is orbiting another G-star at a distance of 157 light years. It is just at a distance from its star of 7 million kilometers. It has 69% of Jupiter's mass. Orbital period is just 3.5 days. The Hubble telescope has found sodium in the clouds of this planet. And this planet is known to have lose hydrogen. It has a 200,000 kilometers long hydrogen tail. And this system has also a higher carbon-oxygen ratio than the solar system, with a ratio of 1. This is my favorite system, that's HR 8799. This is a metal-poor star at 133 light-years distance. It has the star has 1.43 solar masses and almost 5 times the luminosity of the Sun. It's a very young system at 30 million years. Contains 4 big Jupiters, super Jupiters called, and with a mass of 6 to 9 Jupiter masses at a distance of 16 to 72 AU. Orbital periods are between 45 to 460 years. This system was found by direct imaging, and this is a bigger version of the solar system. This artist's image of outermost planet HR 8799b at 72 AU distance from its star has a mass of 5.7 Jupiter masses. Orbital period is around 460 years. This is a picture from its hypothetical moon. It could be that these giant planets that are multiple times the mass of Jupiter, those types of planets could have more massive moons than all the moons in the solar system. And there's one thing known about this exoplanet: has thick clouds, and the molecules water and carbon monoxide were detected in the atmosphere. This is another star, HD 189733. That's a K star at 65 light-years distance. K stars are less massive than the G stars, sun-like stars. This star has just 85% of the Sun's mass and just 33% of the Sun's luminosity. This is a known fact that K stars, hot Jupiters around K stars are less common. However, this star has one hot Jupiter. That's HD 189733b. This planet has a mass of 1.16 Jupiter masses. Orbital period is just 2.2 days. And the orbital speed of this planet is very impressive at 153 kilometers per second. This is a polarimetry image of the planet HD 189733b. Shows the polarimetry of the reflected light. This is a blue planet. You can see, for comparison, the line for Neptune. The estimated temperature of this planet is 1100 Kelvin, and there was CO2 detected in the atmosphere of this planet. We want to know how many Jupiter-type stars are around G-type stars. And it is clear that these type of planets with low eccentricity of just 5% like Jupiter are very rare. And the most common stars in the universe are the M stars, the red dwarfs, with 75% of all stars. And it is known that these types of stars have very few Jupiters. There's a work of scientist Bertram and colleagues. And these scientists think that there's a correlation of Jupiters with higher metallicity. Metallicity is the percentage of elements other than helium and hydrogen. Jupiters with higher metallicity would have a higher eccentricity. This is one twin of Jupiter, that's HIP 11915. It means Hipparcos Satellite Catalog. Hipparcos is a satellite that observes planets. The star is like the Sun, G star, about the same mass as Sun, at a distance of 190 light years. The system is 400 million years younger than the solar system, with an age of just 4.2 billion years. In this picture, you can see the Jupiter twin, HIP 1195b. It has the same mass as Jupiter, It is about the same distance as Jupiter, 4.8 AU. Eccentricity is a bit higher at 0.10. Jupiter is 5%. And the question is, does this system also have an Earth-like planet? It's a very interesting target for future missions. This is another very nice artist concept of an exoplanet. That was today's video about giant exoplanets, the hot Jupiters, super Jupiters, and the Jupiter twins. Thank you for watching. Have a nice day. Bye-bye.